Okay, awesome. So I just started recording. I'll introduce myself again really quick for the recording afterwards. I'm just going to send that to everyone who wasn't able to make it. Hi, I'm Leandra. I am one of the co-founders of Vidcode, and I'm excited to dive into cross-curricular projects with JavaScript today. We're going to go over a lot of different examples, kind of contextualize why we even want to do this. And then go through an activity where we take outside research, make a project together, and hopefully give you the tools and resources to be able to bring that back to your classroom and your subject area. If that sounds good, I'll go ahead and get started. All right, is everyone able to see my screen? All right, I have an affirmative. Awesome. Cool, so let me make this full screen and hopefully it keeps working. Great. So welcome to the Vidcode webinar, Computer Science in Your Subject Area. So I just wanted to start off, and I start off every in-person training with this as well, which is the big idea, why we do this. Why do we want students to code across subject areas? Why not just a dedicated computer science class? What's the point? And part of the point is that part of what we do at Vidcode and what we believe in is that there are so many different pathways to learn to code and so many different applications to learn to code. And when there's only a traditional computer science class available, students might not get the opportunity to see all of that, to see that if they're interested in art, that coding might be relevant to them, to see that if they're interested in science, this can be something that will help them in college and that they can already connect to their existing interests. And so one great way to do that, to make those connections for students, to give them multiple pathways and on-ramps into learning computer science, is to integrate it into the school day and to have these activities that are across subject areas. Cool. So just to get some definitions down, the first is coding. What do I mean when I say that? All I mean when I say it, coding, computer programming, I use the two kind of interchangeably. And I just mean that I'm telling the computer to do something, to do what I want it to do in this case, in a language that it can understand. So in this case, JavaScript, but it could be any language. Computer science as a whole, as an umbrella, is the study of computation. So coding kind of lives under that umbrella, but isn't every part of computer science. Cool. If I ever stop, I'm kind of like managing participants or checking the chat. So computational thinking is another part of computer science and one that gets practiced and refined in programming as well as other parts of computer science. So it's mostly focused, and we're going to go through probably all of these today in our examples. So it's focused on decomposition, so taking a big problem that can be broken into smaller problems. Generalization, have I seen this problem before? Can recognize patterns. Abstraction, so figuring out which details don't matter. Pattern recognition, figuring out which parts repeat. So in the case of my code, not having to write the same code over and over again. And algorithm design. So those are the 5 fundamental skills of computational thinking. And this is important because these tie back to how I can use when someone asks, like, oh, like coding, like what skills does this give me, like outside of just pure programming? And you can kind of see like all these skills, all these ways of thinking that I can apply in other parts of my life. Cool. So what do we give students when we teach them to code? I talked in the beginning about how we want to give students Onramp in classes besides the traditional computer science or tech class to coding, but why? So one, the list here is that we want to normalize computer programming for them. We don't want it to be scary. We don't want it to be something that isn't for them. And that's important. They might not have seen programmers that look like them on TV or in magazines. So it can be important to normalize it in a class that they're familiar with. It helps them identify as programmers, learn the computational thinking skills I went over in the last slide. And it also gives them the opportunity to use programming tools for self-expression. So it gives them the resources to create things they see in the world. If there's an app that they want, it gives them the chance to make it. And in a smaller way, if they just have a game that they want to make and share, it gives them the skills to do that too. Cool. So tying back to that original thesis, I'm going to show you today how in like the open Vidcode Sandbox, you're going to be able to bring your own media into a project. So when students are able to connect code to the things they already like, the subjects they already are really passionate about, and when they're able to bring their own media in, it increases student engagement in coding because they're able to see the connections instead of just working on something more abstract or maybe something that they don't connect to or are interested in. And it increases the number of like quote unquote non-traditional students who identify as programmers. Cool. So after that introduction, does anyone have any questions about anything that I went over? I hope it was helpful. I just sort of wanted to set the stage before we dive into individual projects. So here I have kind of a list of ways and examples that students on the Vidcode platform have tied what they're learning into coding. And that's sort of broken up into 3 different levels. And they kind of go into increasing, not complexity exactly, but ways that the code is used and integrated into the project. So in level 1, students are coding activities that often replace a PowerPoint or augment a research paper. They're doing research on something else and coding a project to show what they learned about that. So the code is used merely as like a means for students to create their own project to replace something like, in this case, a PowerPoint or maybe a diagram. So examples of that, and this can be a really, really great place to start, partially because these tend to be easier projects to program. And you'll see that in the code examples here. They're not too complicated, and they give students an opportunity to show off what they know through code, which is kind of cool. So examples of that include things like showing a word that they've learned in another language. Or in this case, this project was an elementary class, and they were reading The Big Friendly Giant at the time, and they took pictures of themselves and coded scenes from the book. So fairly basic, but brings them into this like very introductory coding project and connects it to something that they've learned and makes them think about the text that they're reading. You can see here, and I'll dive into the actual code editor at the end for those of you who haven't seen it. But the student is just setting variables and modifying them. So this can be something that an elementary student can definitely do, or a student in older grades that maybe hasn't coded before. This one's very cute. There's audio, so be prepared. I'll kind of try and hold my phone up to the computer so you have a chance to watch it. There we go.
years? Wow, that's a long time. Keep it, man.
Cool. I like this one because the students actually went and filmed themselves to make the project and uploaded it, which I thought was very cute. This one too, so the other kind of introductory project that we see a lot used in this way is just stop motion. And that's because it's easy to get started and you can make the connection very quickly about how to use it in another subject area. Something like, in this case, a science class. So you can see through the video the actual life cycle of this frog. The student was able to upload these projects or these images and make the stop motion. So in the examples that are further, another example, if anyone here is a history teacher, a teacher actually made this one. It's a Henry VIII meme. It says, "It's not you, it's me. I grew tired of my aging wife. I fell in love with Anne, and I wanted more power and money." So this is like a history teacher meme made on Vidcode. And before I go any further, I actually want us to take a step back. And for those of you who haven't been to one of these webinars before, show you the coding interface that students use to create the projects that I just went over. And then we can dive into level 2, which is where concepts that students learn are actually integrated into the programming activities. In this case, I'm going to show you a couple examples of sine waves. But before we do that, let's dive into this code editor. So for those of you who aren't Vidcode teachers, I'm not 100% sure what the breakdown is, but anyone can go ahead and access the Vidcode tutorials by signing up. All of level 1 is going to be available to you for you to explore. So here I'm going to go into start coding. And there's going to be a bunch of different activities for me to choose from. For this example, I'm going to show you filters, which is like the absolute very first example. So this is the interface that students actually use to code the projects that you saw. They have instructions on the left, a code editor in the middle, their actual project here on the right, and then a media gallery here on the bottom. The media gallery is part of the reason that it can be so easy to integrate a Vidcode tutorial into like a different subject area, because students are able to take media from whatever they're doing and integrate it into their projects, like the Henry VIII meme or the frog stop motion that I showed you guys. So here, I'm going to go ahead and we're going to do another project together later, so I'm not going to spend too much time here. But I'm just going to go ahead and pick a video, like it's going to prompt me to in the purple text. Whenever I select anything on the Vidcode interface, I'm going to see a one-to-one effect in my code. So here, my butterfly video appears, and I'm able to see the code that makes it happen over on the left. As I click next, there's going to be instructions on the top here that walk me through what I'm learning. And then when I get to step 4, I'm going to have a block appear here. Anyone who's used Scratch is going to be very familiar with this. But when I pull it in, it's going to turn into real JavaScript code. And I'm going to be able to see those effects right away. So as I go through, more of these appear. I can go ahead and play around with my tint, try and make it like green. And as I go through more and more of these tutorials, I start to learn more things. Like I learn how to do things like add text to my video. So if this was like instead of the life cycle of a frog, like the life cycle of a caterpillar. This actually, my keyboard gives me an emoji. There we go. And it's also going to teach me in this, even in like this very first level, to do things like add graphics and modify them. Once I'm happy with a project, I can go ahead and publish it or save it to keep working on it later. So this is the code editor that the students actually used to make the projects I showed before. I just wanted to give you all that context before we went any further. So I can go ahead and publish it. Let's call it Butterfly. And it's going to save and load for my teacher or anyone I wanted to share it with, my parents, on that same page I was showing you all before for the other project. Cool. So let's go ahead and dive into level 2 now that I showed you all the coding interface. So if the first one, the first level of kind of cross-curricular projects, just presents something that a student learned, level 2 starts to use what a student learned and actually integrate it into the project. And the easiest way, I think, to show that is through math examples, because you can do so many beautiful things with sine and cosine. So in this case, and you can see for these examples that the code starts getting more complicated too. So this probably isn't a project I would start with. But as your students go further and learn more and more about coding and want to integrate more complex examples into your class, it's a great way to think about it. So here you can see that I have these awesome colorways that are going up and down, and it really visualizes this beautiful sine wave. And let students actually be able to write math equations and see them live, which is something that is harder to do in things that aren't computation. Here's another project. This is a tutorial that we have on the Great Pacific Garbage Patch. And you can see too, it's that same sine wave pattern, but in this case, it's used to kind of combine level 1 and 2. So it's showcasing something the student learned that in this case, the Great Pacific Garbage Patch is a problem, but it also is able to animate the ocean trash in this really cool sine wave here. And the actual equation for that is down here. So then the third level of these cross-curricular activities is actually modeling student research. So taking something that the student's been studying and showcasing it with code, using a programming activity to create an interactive piece that people are able to explore to learn more about the subject. So some examples of that can be as small as graphs. So in this case here, a student was able to make a graph for slope and intercepts, and I can go ahead and change these numbers. And see how it'll actually affect the project. And something like this shows student understanding of not only programming, but something like this math equation. They're able to understand it and create something that showcases that understanding and can teach others. Another great example of that is this simulation of the eclipse. This is actually another tutorial. This was in our code 1 year. So as my moon gets further away from my sun, everything gets lighter. And then as I get closer, things get darker, and then I get this effect when I go directly over it. Something that's a bit more hands-on that you could actually see an example of the research of is something like this simulation of when something turns into solid, liquid, or gas. So this particular example doesn't have numbers on it, but it could. And it could show students' own research in the lab about when something would turn from liquid to temperature to gas. And they're able to actually create an interactive simulation showing what they've learned and letting other people interact with their data in a way that would also be hard outside of a computational project. So I can see when something turns to gas. Let me try and get, there we go, there's water. There we go, we get ice. Cool. And this doesn't just have to be in one subject area either. We've seen some really awesome examples of classes that have come and worked together to make different projects on Vidcode. One example is the 6th grade English class. They actually worked with the art class in the same school to make postcards from the book they were reading, Swallows in Amazon. So the class thought about the book they were reading, chose different places that the main character had gone, and made different postcards for those places. And they thought about things like the time period, they thought about things like the local culture, as well as the mood in those books during those scenes. And they were able to bring all of those things into this activity where they created these postcards that you can see on the right. And you can see something like this, it doesn't take a lot of code. Students are able to upload a project, click on it like you saw me do with the butterfly, and then just add text, add a rectangle, and go from there. Cool. So now I want to go ahead and actually go into an example of how we would do this, kind of starting from scratch. And then hopefully you'll be able to go through the same process with your existing lesson plans and make a project that could tie back to a coding project. A lot of times I'll see when teachers do this, they'll go through a couple tutorials beforehand just to give students a feel for Vidcode and what they can do before they start planning it in a more cross-curricular way. So if you're choosing to go that route, I'd recommend starting with Create a Filter, doing Make a Meme, and then hopping up to Cross-Curricular Coding Kit and doing Slideshow. And then with really just those activities, that should be enough for students to have a basic understanding of coding and the Vidcode interface to be able to start to plan and create their own cross-curricular projects. So in this example of a curriculum integrated CS activity, I'm going to pretend that I'm in a science class. And we could start with possibly just showing students an example off of Vidcode. So what people have done. And so I'm going to have me, in this case, go through research of live graph data of sea ice from the NSIDC. I'm going to interpret the data and draw conclusions about it, plan a project. Storyboards work really, really well for this. If students just get a piece of paper, draw like 8 boxes on it, and have like the left side be pictures and the right side be kind of pseudocode and notes for them to refer back to. And pseudocode is just like what their code could be on the computer, but it doesn't have to be perfect. It's more what the code does. So instead of writing the exact coordinates, I could say like this graphic is in the middle of the screen. So let's go ahead and watch this hook really quick, what I might show my class in the beginning of this assignment.
You know, for a long time, people have mostly just cared about themselves, or their family, or their clan, or their tribe. They weren't really trying to look out for people around the world that they never met. But I think that's changing. It's time to expand the reach of our compassion. In the 1800s, fossil fuel was progress, industrial revolution, burning coal like yes, but that was the spring of industry. That was August, and if we don't cool it.
All right, cool. So we don't have to watch this whole video, but I might show something like vocabulary to get students thinking beyond just an initial Vidcode project. And yeah, just to like help them get creative about how they might be visual or create other media from research. So that would be my goal of a video like that. So let's go ahead and open up this sea ice data really quick. And as a class, you could explore whatever your research topic is together, or you could have students go through it alone. For younger students especially, we see things like this work best when there are workshops or like conversations on things like what's a fact, what's an opinion, what are trustworthy news sites, how can we tell? And those are great digital citizenship kind of like conversations and opportunities anyway. So it's always a really great opportunity when there's a chance to combine those with a coding project, since those are both kind of ways for students to build that positive digital citizenship. So in this case, I'm going to go ahead and explore this data that I'm going to be making a project from. Let's see. So there's all of this news. We're in our autumn regrowth period of Arctic ice. So I'm going to go down here, and then I think a really great place for me to start would be satellite observation. So I'm able to dive into any of these areas and see more about this. I'm going to go ahead and go into sea ice. Seems pretty straightforward. And it's going to give me this interactive project to see the change over time. And this isn't what your students have to do. This is just one way that I might go about going through a project. So as I click around and learn more about it, try and like see how the anomalies have changed, I can create a piece of evidence or like gather evidence and write one thing kind of overall that I've learned from it and add that to my video. So in this case, from this graph, if I start in 1990 and go up and see how things have changed every 5 years. One takeaway could just be that sea ice cover in the Arctic Ocean has decreased from 1985 to 2015. And you could have students go further than that, but for this example, since we don't have a lot of time together, that's the fact from this evidence that I am going to make my project about. So back on Vidcode, I'm going to go ahead and decide that the best way for me to showcase this data, and I could use any of the projects that we've gone through. In the cross-curricular coding kit, I have things like code a news broadcast that I could do. But in this case, I'm just going to make a stop motion or a slideshow. So to make a slideshow, I have to get my pictures in a certain order and upload them to be able to do that. So I'm going to go ahead and upload the pictures that I have already taken from that sea ice anomalies graph. And once they are uploaded into my interface, I'm able to keep following the instructions, and it's going to prompt me to actually write a line of code. So I'm going to go ahead and do that. And then click these pictures to add them to an array. And this is an example of an array. So just a list of things inside these brackets. I can see by just looking at this that I actually got two things out of order. So instead of starting all the way over, I'm just going to copy this file name and move it after this one. This is a great example of why naming files is super important. If I was trying to do this without having renamed these files, and they were all named as random things, I'd have a really hard time knowing which order they should go in. So if I keep pressing next here, it's going to let me know that a bit more about arrays. And then it's going to, oh, it's giving me a quiz. It's going to give me the code to actually animate my project. So let's go ahead and do that. I'm going to copy this in. And I'm going to get to see this graph change over time in this animated way. If I wanted to speed it up, I could make this number lower. If I wanted to slow it down, so you don't maybe get to like see it as, you don't get to see the animation as well, but you get a chance to like look more closely at each 5 years, I could make the number bigger. Cool. One of the prompts on here is to apply filters to make my video stand out and get my message across. We went over what video effects are available in that creative filter project. But if I, as a student, ever want to go back to a previous project, I can just go ahead and open this reference here, go down to filters, and see all the options that I have. So if I wanted to do something like add a vignette, I would be able to see how to do that. It's, something like that. I probably don't want to add too many effects to this one because it might make it harder for whoever's looking at this to see the data. So if I did something like add like a filter that changes color over time, it might get my point across that CA's cover has decreased. Like if I start it really blue and bring it down, but it would make it harder to actually see the data that supports that. So these are kind of like the aesthetic versus showcasing research decisions that a student has to make, which is so important and interesting because these are the kind of decisions that professional software developers have to make all the time, and designers. So the other thing that I'm going to add here in this project, this is looking good. I like it going a bit slower. I'm actually going to get rid of this vignette. I like that you can kind of see it over time. So I actually think, I'm not sure if this will work, but I'm going to try and add a motion blur. Oh, it does. So you can kind of see my motion blur like merges my effects together. But that also makes it a bit harder to see the data. So I'm not going to use that either. One last thing I'm going to add, so whoever's looking at this doesn't have to come to the conclusion that I came to through this evidence. I'm going to add text that includes my conclusion. So here I'm going to go ahead and go down to shape in my reference and go ahead and find rectangle. Here we go. So I'm going to copy this in to draw a rectangle. Rectangle, the code that gets passed in, and if this is confusing, it's okay. Like I said, normally in the 6-hour training, we would have gone over tutorials that sort of introduce this. And if you do want to go through tutorials that introduce this, make a meme is a really, really great place to start. That's just in level 1. But here I can see that the things that are getting passed in are the X position, the Y position, the width, and the height. So I know I want to start at a 0 X position, which is going to be left, right. So it's going to be here, and I want it much lower. So I'm going to put it down at like 550 because I don't want it to cover too much of my graph. Awesome. And then I want it to stretch all the way across. So let's make this a really big number. Oh, wait, that's width, or that's height, I mean. There we go. Okay, so now it's stretching all the way across. The other thing I could have done is, for those of you who have used P5 before, I could do something like movie.width to have it do that math for me automatically. So now that I have this down here, I'm going to go ahead and actually change the opacity so it's a bit see-through. Change it to a nice blue color. And then I'm going to go ahead and use this as the base to add my conclusion on top of. So here I'm going to just write out, and this is another thing I could find on the reference, but I'm just going to type it out here. So var conclusion equals text. And then the conclusion that I came to before. So C, I cover. And then I'm going to go ahead and set the Y position down to where my rectangle is. Okay. All right, there we go. So we can see that it's a little bit too large here. I have a couple options when that happens. One is that I could change the actual size of my text. So I can make it smaller. I can make it a bit too hard to read. In this case, I actually think it's fine, but the other thing I could do is actually break it up into 2 lines. And this would be a great place, we went through try and find repeating code. This would be a great place to get rid of repeating code as I get further into my coding journey. So I'm going to change this to line 2 and has decreased from 1985 to 2015. So I think that lets us be a bit more readable. So let's go ahead and make this 50 or 40. Make this 40 and bring this down further. Okay, great. I don't think that's super readable. I'm going to make it white. And I'm going to make my opacity a bit lower on my box. And then I have this awesome project that's showcasing evidence from a research site that I found, as well as my conclusion in the project. So I think this would be a great piece that could go with something like a research paper that uses data from this site. So if I wanted to, I could go ahead and copy this. And when I publish my project, I can add something like over time uses data. So I'm able to pull in my sources right in the text of my project. Oh, there it is. So I hope that you're able to kind of take that process that you just saw me go through and apply it to what you're teaching right now. So whatever research site students would go to do a research paper they're doing, or whatever books they're currently reading in something like language arts class. Just to show you another example of something in that, I did this one before the webinar started, and it actually has two of those graphs on top of each other. So it has the vegetation graph over the Arctic land graph, has the numbers updating in the top left corner, and has a bar graph that mirrors the bar graph on the website where I got this data to show the change live. So this is sort of another example of a way that using computer programming can help illustrate a point and even take the visualizations on this website and use them in different ways to be able to do things like stack them on top of each other and really see the change live animated over time. And then things like having the graph update also are things that I'm able to do very easily when I have that data collected and I'm able to represent it in a new way. So that's all. We're right at the 50-minute mark, which is amazing. So I would love to hear from you if you have ideas about how you would use research related to your own subjects, or how you would bring computer programming into your class. And I'm actually going to go ahead and stop the recording here, but give you all a chance to kind of share in the chat